So these are my colleagues, and we work together in various capacities, but more specifically, we attended the last Biohackathon in Barcelona, and this presentation is a bit a report of what we did there and where we are at the moment. Next slide, please. So as I've mentioned in my previous slide, for those of you who are new here, in the previous talk, I talked about GeneWiki. And what happens in GeneWiki is that we create bots that take data from primary resources or established life science databases on genes, proteins, diseases, and chemical compounds, and we align them with Wikidata. After doing so, we have a landscape, a life science landscape in Wikidata. We want to reuse, but that's where we run into issues. Next slide, please. So this is a typical curation cycle. There is a disease ontology which has its own curation cycle. There is the Wikidata. There's Wikidata that has its own curation cycle. And what we do here is by aligning a disease ontology to Wikidata, it's being curated on Wikidata as well, and that information is then put back to the curators of the disease ontology. And this is an ongoing effort. Next slide, please. But when trying to get the data, this is more and more the screen that we see. And this is just a simple Sparkle query where we want to use all the DOIs. I cheated a bit here because, of course, but it's not, well, I wouldn't say it's cheating, because for some use cases, you really want to know what are all the DOIs that are in Wikidata, and using the Wikidata query servers, you will not be able to extract that information for Wikidata. And that is not only the DOIs, and it works for gene IDs, for chemical compounds specifically, which has 2.1 million items in Wikidata already. So getting that out is problematic. Next slide. So what we have been doing since 2019, and we have been meeting at hackathons, specifically the Biohackathon and the SWOT for HLS hackathon, which is a hackathon run by folks working in the life sciences, and initially started in 2019. Then Brickley started the subsetting tasks, which we joined at the SWOT for LS hackathon. And the idea is, how do we get subsets from Wikidata to do more complex stuff? So the moment you run into the 1 minute delay, timeout, sorry, you want to do more complex things. So we went there, and in the last hackathon, which was in November, and this image is from there. So there were some folks who could meet in person, and others were online, hence the hybrid nature of the hackathon. We met in, I think, 6 hackathons since, and to this, the following talk is our report back of the results in getting subsets from Wikidata. And I think that's your cue, Jose.
Okay. Hello, can you hear me?
Yes, I hear you, and I see your slide.
Yes. Okay, yes. So I was going to talk about the report of the subsetting. First of all, some motivation of why we want the subsetting. I mean, the main motivation, as Andra told, was timeout queries. And those timeout queries is because, I mean, the Wikidata is really a success, and it is huge, and there is a lot of data, and that's great. So that's successful. But also, if for the researchers or anyone who wants to work with the data in Wikidata, Wikidata is like a big monster, full of data, so which is difficult to handle in small devices. So if you want to to be able to process small amounts or in some specific domains of the data of Wikidata, it is currently quite difficult. And also in a more research, some of us are researchers, we wanted to do some experiments with the data in Wikidata, but as the data in Wikidata is continually evolving, continually moving, it's a difficult target, and it's difficult to create or even to try to have a paper with data from Wikidata where you know that maybe the next month the data in Wikidata will be changed, so it's not difficult. So what you would like to have is some kind of a snapshot or snapshots of the data in Wikidata, so you could later reproduce with that data and some analysis or some experiments that you want to do. So I think from that research point of view, it makes sense to be able to create those snapshots or subsets of Wikidata. And also, I added here also this Scholia, because this summer we were collaborating with people from Scholia. It was more experiment to see if we were going to be able to improve some of the things that could be done in Scholia with a subset of the domain of Scholia. This is still work in progress, but and this is the report of what we have been doing. So the problem statement is quite easy. We have Wikidata, which is such a huge amount of data, and what we want to have is a process, a subset creator, a snapshot that creates a subset. So this is the Wikidata subset that maybe we are interested in that. Of course, if we want to do this task, this problem, we need to describe how we want to, in which, for example, in Scholia, we are interested in researchers, in scholars, in papers and citations, maybe organizations. But if you start to link things, maybe you are also interested in countries and in topics, and if you go to topics, then you have genes, and so it's quite difficult, and you want to define a boundary of the things that you are interested to create that subset. For that, there are several things that you wanted to describe. For example, nowadays there is already a technology which is used to describe and is also used to validate, but can also be used to describe contents in RDF, which is shape expression sex. So that's also one of the motivations we had for that, is that we were working with shape expressions which are able to describe RDF data, so they could describe also the data that you are interested in Wikidata. So that's the main thing. So we want to be able to describe that. So we want to describe the subsets to obtain those subsets. And now that we open this box of Wikidata, you can see that Wikidata, there are several things here in Wikidata. There is the database, which is almost like a big relational database. I think it's MariaDB. There is also synced with BlazeGraph, and from BlazeGraph we obtain the Sparkle endpoint. And then we also obtain these other different views. We obtain from some frequency, we obtain the RDF dumps, we also obtain the JSON dumps, and then we also obtain, through using the API, we are able to obtain the JSON view of the data and an RDF view of the data. So this is, I talk this because when we create the different tools these creators of subsets, they work in different ways. So that some of them are using the Sparkle endpoint. Other tools are using the RDF dumps or the JSON dumps, and maybe they could also use the API. So at this moment, this is so it depends on the tools. And at the end, what we were working in this hackathon was especially in the last hackathon, was to identify the main possibilities, the main tools that are already appearing that could be used to do this subset. Because at the end, we created this table This table is, and the goal of this table is that depending on the use case, I mean, maybe you want the input data to be a Sparkle or JSON dumps or a table. So you also you want to describe the subset using shape expressions or with JSON configuration files. Maybe you are interested to know what's the output format and what are the infrastructure that you want. Maybe you only have a small laptop, or you could have a Spark cluster. And then you also maybe are interested in support for qualifiers, references, and so on. So this table, what I will do now is to give an overview of every row here, so to describe what it does. So the first one is the first approach is to use using shape expressions and entity schemas. There is an option in the validators that is called SLARP, and what SLARP does is that at the same time that you are validating the RDF data, you are collecting the data that is valid. That you, for example, when you visit a node in the graph that you are validating, you collect that node and also the triples. The advantage of this is that you, at the same time that you are validating data using this shape expression, you can also generate the subset. So we're using this option of a SLARPer. So this works. You don't need to do anything else. This is just an option in some of the validators in the Python in the JavaScript implementation. They support this option of SLARPing. They also traverse the graph, which is an important class of another item. You also want to traverse the graph to 10 items. So this option you can do that. But also this option has the problem that it is working using the Sparkle endpoint, and the Sparkle endpoint has some timeout problems. So this has the problem of scalability. So at this moment, this option that is traversing the graph and using the Sparkle endpoint, it works for small samples, but it's not quite scalable, and we are looking for other alternatives. There was already an alternative. This is a tool to traversal processing the JSON dumps, go entity by entity. I mean, it's a full dump. Is every entity in Wikidata is a line, so you can traverse line by line sequentially. So you can. It's nice, but you cannot traverse the graph. So this is the tool that it is already existing. So and also Sayed is going later to explain more details of how he has been using this tool. Then there is a quite recent tool from MaxDAT that is this wiki-based dump filter. It's very similar what he does to WDumper, but there is a difference. The difference is that he generates JSON dumps, while the previous one was generating RDF dumps. And if you generate from JSON dumps, you generate from JSON dumps, you generate also JSON dumps. You can chain different creation of subsets. For example, you can create from the Wikidata, you create a subset, and from that subset, you can create another subset, so that you could chain those creations. There is another tool is WDSUP. This is the tool that I have been implementing. This was implemented by me, and this tool has the difference between the previous ones is that they use as input JSON configuration files, but in this case the input is an entity schema, or is a variant of sex, which is I called WSEX because it handles qualifiers and references. And this tool is also processing JSON dumps line by line, so it doesn't do graph traversal, but it was able to process the Wikidata, for example, in 5 hours. It processes it, but this is still work in progress because it doesn't support all the possibilities of shape expressions. We're working on that. And there is an alternative that I was working in this summer, also for this collaboration with Scholia. that I wanted, I didn't want to process only one line and sequentially, but I wanted to process the whole graph. If you want to process the whole graph, I found some algorithm for large scale graph processing, which is Pregel from Google. So I did an implementation of this algorithm to validate shape expressions and also to obtain subsets of shape expressions, or from, I mean, in this, sorry, subsets of Wikidata using shape expressions. And it works, but it requires a lot of computational resources. So at this moment, I still need some time to improve this implementation. The nice thing is I was able to process the whole Wikidata dumps, the latest ones in last year, in 36 hours. So it was impressive, but it was also very expensive. I mean, it was it required 512 cores, and I mean, I still need to improve the algorithm, but also this is using Apache Spark. It is this tool. I think it's the last. The last one we was reviewing was another approach made by this tool called, I think we will have one presentation of KGTK. Um, the nice thing of this tool is that it is impressive, the numbers that they are. I mean, I think they work with SQLite in memory, and they obtain the JSON dumps, and they are able to process it very fast. They are very, I mean, they are very efficient processing it. Maybe something I would prefer is that the input language for this is Kaifer, which is a specific language, but and then they generate these TSB subsets. So this is this tool. So here, this is again the overview of the comparison. Oops, the comparison of the different tools that and the table that we were developing. Uh, of course, we could add other approaches. There is another approach I didn't comment, which is just based on doing a Sparkle with construct queries. You know, with a construct query, you can create a subset. So there is also this approach, and it has some advantages and disadvantages. I mean, it's a matter of finding the trade-off, and depending on the use case, what you want. So this is the main result that we did for the Biohackathon was this table, and of course we are still working to improve some of the tools. Well, finally, the last thing that we were also talking and discussing in the Biohackathon, well, there are other things, but related with subsets was what we could do with the subsets once we create those subsets. And there are different options. So one option is to download. I mean, you can just download the subset and do whatever you want with that. You could put the subset in a Wikibase. So we were also working, for example, if you have the JSON dumps and you want for a subset of the JSON dumps, you want to replicate and to create a Wikibase. So we created some fabricator issues for that, and we're working on that. Maybe you don't. I mean, the difference of Wikibase and RDF triple store here is that in the Wikibase you have more things. You have all the things that we have in Wikidata, but for your subset. But in the RDF triple store, you are only obtaining the RDF version, which has a different view of the Wikibase. Maybe another possibility was the HDT. HDT is a compressed version of RDF, and it usually is only for read only, and this probably is the more performant way. For example, for that use case of where you are a researcher and you want to have an experiment and you want to accompany your experiment with the data, and so you have a compressed version of your data. That maybe that compressed version of the data is in fact a subset of the Wikidata, a snapshot of the Wikidata at that time. And finally, of course, there is also the possibility that once you have the subset of Wikidata, you want to transform that subset into another subset. Maybe you are interested to convert some labels to another thing, or you want to map some things. And finally, you could also enrich the subset. Maybe you have this subset and you can enrich it with adding some labels or whatever. And this is also some actions that we notice that people really want. I mean, once you imagine that you obtain from Wikidata information from researchers, and then you want to enrich that information from researchers from another triple store that has other information about experiments or whatever. Okay. I think that was all from my part, and now Sayed, you can continue.
Yeah, can you hear me?
Yes. You want me to continue sharing the slides?
Yes, please, if you can.
Yes.
Great, thank you. Hi, everyone. Thanks for coming. So my name is Sayed. I'm a PhD student at Heriot-Watt University, and my research focus is data quality, in particular reference quality of Wikidata, and I've been also involved in the last couple of biohackathons. I'm going to start with a brief introduction to topical subsetting and random subsetting, and I'll continue with WDumper, and finally I will talk a little bit about the interaction between Wikidata references and subsetting. Next slide, please. Topical subsets are a specific type of subsets that are formed around a specific topic. This topic can be anything. It can be very simple and be expressed in one word, for example, politicians. And it can be more complex and have several conditions. For example, British politicians who lived in the 17th century and were also military, for example. Anyway, we consider topic, we specify the conditions and boundaries of the topic. We then extract all or part of the entities in Wikidata that conform to the topic. And we also select all or part of the facts about the selected entities. So topical subsetting is actually a form of entity-based subsetting because topics are mostly applied to entities, at least in my definitions. The notion of topical subsetting came across when we were trying to evaluate WDumper as a subsetting tool, which I will explain in the next slide. We established, sorry, can you just take it? We established some experiments for evaluating the tool, and for those experiments, we needed some use cases. We decided to define 4 topics. Well, there were some technical reasons behind them in terms of boundaries, but about the subjects, there was no specific reason at that moment. We just took them out of the blue. The first use case was politicians. It's very simple. It covers just one type and there would be no conditions. The subset should bring together all instances of humans whose occupation is politics in Wikidata. The second is military politicians with the rank of general, so it still covers only one type, but with more conditions. We had also a use case with a relatively smaller output, which was UK universities. And our last use case was one of the Wikidata Wiki projects, GeneWiki, which was at that time a combination of 17 major life science entity types. Next slide, please. Thank you. So GeneWiki extraction was very interesting, and because of that, in the next paper, we focused more on Wikidata Wiki projects. There are many Wiki projects out there, maybe at least 300 active Wiki projects. You know, Wiki projects carry the concept of topicality with them. They are topical in nature. They are all formed around a subject. Wikidata editors add and maintain data about that subject. Many Wiki projects have specified things that fall within the scope of their subject, and they already have documented the boundaries of their cover topic, and these documents are already available on the Wiki project's Wiki page. This information can be used to accurately define the subsets. So Wiki projects are great candidates for topical subsetting. And in that paper, we have extracted 6 subsets corresponding to 6 Wiki projects, which were astronomy, GeneWiki, taxonomy, music, law, and ships. Next slide, please. Thank you. So a very nice description of topical subsetting that Jose also mentioned, and I'm borrowing from Dan Brickley, the example, is that topical subsetting is like cutting a plant and placing it in a new pot. So it can grow and become a new topic-specific knowledge graph, even better than its original knowledge graph. Consider, for example, the extraction of GeneWiki. So we can create a new wiki base, importing the extracted GeneWiki subset and populating it to be a new life science knowledge graph based on Wikidata data model. Next slide, please. Okay, so let's now talk about random subsetting. While topical subsetting would be more useful in populating new data sets, random subsetting would be more useful in evaluating experiments. Random subsetting is somehow the way we can sample a knowledge base. And this sampling could be entity-based. So we will select n QIDs randomly from Wikidata with all labels and descriptions and metadata and qualifiers and references. Or it can be fact-based, in which we select m statements randomly, again, with all qualifiers and references and items that are connected to those facts. And please note that here we are talking about big data with millions of triples, not small subsets. I remember in one of my submissions to a workshop, they rejected my subsetting paper, saying that the subsetting problem is so trivial that can be done even with a simple Sparkle query. So if you think like them, please don't. It's not as trivial as you think. There are many engineering and technical and also theoretical challenges here. Next slide, please. Okay, let's speak about WDumper. So at the Biohackathon 2020, I think we found the WDumper tool in one of the Wikidata wiki pages. It is a third-party tool designed to create custom RDF dumps of Wikidata. Very soon, it turned out as a good way to create topical subsets. And recently, with minor modifications, we are able to extract even random subsets from Wikidata with it. Big random subsets. This tool is based on the Wikidata Toolkit, which is a Java library. It has a Python frontend GUI to define the subset that you want. The GUI creates a JSON specification file. Then the Java backend gets this JSON specification file along with a complete Wikidata dump, JSON dump, and creates an RDF subgraph as the output. In fact, with the JSON specification file, you will define some filters on the items and statements that should be extracted, and then Java backend will extract the matched items to the filters. Next slide, please. Yes, so here you can see an overlook of the WDumper backend. So based on filters you define, WDumper first finds the matched entities. Then for all selected entities, it will select the specified statements and other metadata like labels and descriptions. The WDumper backend works fine and it's accurate, but we already evaluated it. It will extract what you specified. The output RDF is out of errors. Its extraction time on a full Wikidata dump would be about 10 to 15 hours. The time, of course, would be very dependent on the hardware you use and also in the number of filters you specify. Next slide, please. Yeah, I would like to talk a little bit more about the structure of WDumper specification file. The format, as I said, is JSON. There would be three main sections in the file. First, you would have the general filter section, which are actually public filters and will be applied to all selected items. Second, the statement section, where you select the type of statements that you want to be in the output. And finally, the item sections, where you specify the items that should be in the output. So here you see the first section, which is general filters. You can choose whether the selected items should have their RDFS labels, for example, whether they should have their descriptions or not, whether they should have additional metadata like RDF type triples, whether site links should be in the output or not, and so on. Next slide, please. Yeah, okay, in the second part, you can specify some filters on statements. Those filters can be general, like the first blob on the left side, which says in general for all selected items, the output should keep the references but doesn't keep qualifiers. And also it will keep the full statements and ignore simple statements. Or the filters on statements can be specified to a limited type of facts, like the second blob, which says for P31 and P279 statements, ignore references and keep qualifiers, and also keep only non-deprecated facts. And note that the general filters and specific filters will be operated as logical OR on each other. So the next slide, please. Yeah, at the end, you can define filters on items as well. Filters on items would be based on properties. So you can filter items that have a specific property or have defined or have a defined value for a property. For example, on the left, you see two blobs again. The first says that please select items that have musician occupation. So it is based on having a special value, which is to be musician, for a special property, which is occupation. The second is saying that select any item that has the P31 property. It does not matter what value it has. It should only got a P31 property. So the next slide, please. Yeah, so to summarize the pros and cons, the most important thing about WDumper is that it can use any type of Wikidata PIDs as filters with no limit on numbers. And it also will extract all desired entities and all statements of them as well, and also all extra metadata like qualifiers and references. But on the other hand, WDumper has limitations that are mostly related to its filtering system. For example, WDumper cannot use property paths and path extensions, which are very common in SPARQL queries, and it would be bad for detecting type hierarchy, and you cannot, for example, automatically extract subclasses of a class of items in WDumper. It also cannot have connections between filters. For example, you can select humans, diseases, and also genes in different JSON blobs, but you cannot force it to select those genes that are related to a human disease. And such a connection between different filters cannot be done in WDumper. And the next slide, which is finally, I think my final slide. So, which is about the impact of references and subsetting on each other. First, about the impact of subsetting on references. The most important effect of subsetting in the context of references is studying quality evaluation. And subsetting has two important benefits here. One is that you don't need to work on a complete Wikidata dump, which is also ironically very large. So a poor PhD student like me certainly would not be able to rent a virtual private server with 2 or 3 SSD drives to load a full Wikidata dump. But he could easily work on smaller subsets on a River laptop. Another benefit is that subsetting provides a platform for comparison. So when you want to evaluate references in knowledge graphs, well, the only knowledge graph that supports references is Wikidata. So you have no other basis for comparison. But with subsetting, you can have more variety and compare results between some random and topical subsets to see the difference between at least 2 or 3 smaller knowledge bases. On the other hand, references can also play an effective role in subsetting and act as a very important filtering base. This effect can be considered on 3 levels. In the first level, it is important for us to be able to filter based on the existence or absence of references. For example, we may want to ignore all non-reference statements. This level is easily doable by wdumper, for example. In the second level, we may want to be able to filter based on reference properties, reference-specific properties. For example, selecting all statements that have a reference URL or have a retrieve date, for example. At the last and most complete level, we want to be able to filter based on reference values. So Andra had a very good example on this. And it was like, okay, assume that an internet society believes that the earth is flat. I want to remove any statement that refers to this particular society website. In a more complete action, we may even want to bring Wikidata history on board and ignore any statement that is referenced by a member of such a society. And of course, the second and third level are something that wdumper cannot handle, but hopefully WD-sub can handle in the near future. Thank you. So I think my part is complete. And yeah.
Okay, thanks for having me. And I'm going to go ahead and put the slides. People can view them too, because there might be some links people want to click on. So I'm going to put that in the chat. So I'm Saba, and I'm going to talk about wiki-based dump filter, exploring it as a user, and kind of like mostly talking about the use case for it, and then how I was using it. So we're on slide number 32 for anyone that wants to click on things as we go along. So next slide, please. So basically, I think this is maybe preaching to the choir a little bit, but you know, with more curated data in Wikidata, we have better, improved results. If you click on that link underneath the GAB RG2 to epilepsy relationship, that will take you to the protein box plot page. And then go ahead, next slide. And so this is an example, ClinGen, of how we have different jobs running through the protein box plot. So if you click on that link that's on slide 34, that will take you to a page that will show all of the bots, ClinGen being one of them, and that runs under the protein box plot. And then basically the ClinGen bot, what it does is it, and that's something that I put together with the help of Andra and some others about almost 2 years ago, I think. And it's been running basically automated since that time, but basically it automates data on a weekly basis from ClinGen, which is gene and disease relationships for humans, and uploads that into Wikidata. And then next slide, please. And then we run that through Jenkins. So that's, I guess, also similar to AWS, where that basically acts as a way for us to see how the performance of each of these jobs are running through the protein box spot. And then protein box spot is what you actually can able access through Wikidata. And so this is basically one example of many of just automated data integrations that we have for basically working with specialized biomedical databases into populating that into Wikidata as this biomedical knowledge graph subset. Next slide, please. And so my project is mainly working to reproduce this figure from the eLife paper. So Andra already talked a little bit about that work. And so basically the algorithm, it's a logistic regression adapted from Project Repetio, and it has these features as graph metapaths. Next slide, please. And so what this does is basically what you're looking at here is that everything else being equal, the only difference is time with these lines for the AUC ROC curves or AUC curves. And what you can see is that basically as Wikidata continues to get curated with more information, the performance improves. So we are really interested in continuing this for the years going forward of 2019 to 2022. And then we can apply that analysis for then seeing different candidates and drug repurposable drug candidates, which Andra talked about with the paper. And then this is how we get this is we get these results by working on a subset of biomedical nodes and edges, and so that we have that biomedical knowledge graph. Next slide, please. And so then the idea is to continue to reproduce this analysis for years 2019 and 2022. And then, as was referenced before, how there's this query timeout issue with Sparkle. So before, this analysis was mainly operating or relying heavily, not the early part of it, not the analysis itself, but the early part of getting the data, the subsets of the data relied on a Sparkle query. And so how do we overcome this timeout issue? Because it's really a good thing that Wikidata is getting more and more populated with data, but then we ran into this problem with Sparkle query timeout, so then how to address this. And so next slide, please. And so just a summary of what my project is just to, as a user, basically coming in, wanting to reproduce this analysis for drug repurposing. I already have the code from the eLife paper with the algorithm from Project Repedio, and we already know what that looks like for years 2017 to 2018, expecting to get a slightly better improvement for years 2019 and 2022. Not one, of course, but something realistic, but a little bit improved. And here's an example of what that ranking looks like through the HET network, but it looks similar also for Wikidata. Next slide, please. And then that pipeline looks like, so, basically reproducing, so mainly on step A, reproducing the analysis, then automating it just like what I showed you with that small example of ClinGen. And, once I have that code up and working well, then automate it like I have with Jenkins, with the ClinGen job through Protein Boxbot and Jenkins, and then apply that to other years. And then going forward, compare to other algorithms like Semitype. Semitype is one example. There's a whole bunch of them out there. And then also comparing to other biomedical knowledge bases like HetNet, MacReproNet. There's a lot of others out there. And eventually trying to establish a user interface like ClamBase or something along those lines as an extension of this work. Next slide, please. And so then this is kind of where coming all the way back to using Wikibase dump filter and how that goes into the context of WDumper and WDSub and the other examples that were brought up. So the main difficulties and obstacles have been different versions of the code. There's this, our code is available through the eLife paper as WD or Repedio analysis. You can click on that link on slide 41 and it will take you directly to that repository. Metapath is a more recent update. And so kind of trying to find a balance of using that original code for comparison, but also trying to have it be updated just with the code itself and the packaging. Next slide, please. And then trying to get clarity of the nodes and edges of the network. So in the time that's passed, there might be some adjustments, or there have been some adjustments of how we label the nodes being basically item pages and the edges being kind of statements within the item pages, and getting clarity of how we want to define those nodes. So the nodes we've more or less cleared up, and now trying to clear up how we're defining the edges as those have changed in terms of their semantics in the last several years. Next slide, please. And then this is kind of what brings us to the bread and butter of the talk, where we have, a big push in good ways on certain categories like compounds. There was a massive dump where it was, I think, in the thousands before. And then after that dump, it's now 1.2 million. So that's really, really great for the purpose of our result output for the drug repurposing analysis. But then we run into this issue where Sparkle query service maxes out after 60 seconds, right? So that's where we're putting together this work and presenting this to you now, mainly trying out these 4 methods, but then you saw in that table all the other methods that were brought up. So basically, I came into the Biohackathon with this problem of running into this wall and not quite figuring out how to get past it. So then I approached the group through the Knowledge Graph channel, asking them, how can we address this? Are there any other approaches besides these ones? And then that's how we came up with that table. And I specifically tried out the Wikibase dump filter. And then as Andra and Jose and Sayed mentioned, they tried the other ones, or they've talked about the other ones with WD Sub, Spark WD Sub, and WD Dumper, as well as KGTK through Philip. Next slide, please. And then, yeah, just focusing on, my focus has been to try this through Wikibase Dumper. Next slide. And then just my own personal learning curve. So my background is not in bioinformatics, so just learning the process of coding and programming. And I am doing bioinformatics now, but it's not my background, so just getting familiar with that. Next slide, please. So then kind of bring everything back full circle. So I would say the overall thumbs up of using Wikibase dump filter, and then the documentation is in this slide, slide 46, if people want to go further into it. Is it's really well organized. The documentation is really easy for me to understand as a user and walk through it. Anytime I had any issues, I would just post a question to Maxla, and he was very, very quick to respond, and I think even chatted with us here and there. It's nice to work with the JSON files basically directly from the data dump, because that's what we get from the Wikibase archives. And then the metrics for the items are about the same, and so we compare. So far in our results, we mainly focused on those categories of gene, disease, protein, and what was the other one? Compounds, just to see how it would compare. And we get pretty much the same metrics across WD Sub, WD Dumper, and Wikibase dump filter, so that's good. The biggest downfall is that it just takes a really long time, and there's this pre-filter feature. It's just really just a graph aspect of using Wikibase dump filter, but it still takes a long time. I think Sayed briefly mentioned how much time it takes for WD Dumper as well, and it's just difficult to say, there's not really much that can be done, I think, about that. I think it's just basically whatever your tool you're using is going to make it influence, but whatever time it takes is the time it takes. But that's pretty much it. Everything else, I think, is coming together and looking good for this after getting through some of the bumps that were mentioned already. And so that's everything for my section.
Okay, so I think, the challenges and the discussion now, I think we can just do it as a question and answer. We have several topics here, but I think that the message that we can send is that this is a work in progress, and I think here Saba is like and Sayed is like they provided the use cases, and in my case, we were trying to support those use cases, and let's see where we work. But I think that these are samples of use cases, so maybe there are a lot of other people who maybe don't realize that they really need, or they really would be very happy if they are able to obtain subsets from Wikidata in a very easy way. So I think with that, maybe we can go to questions and answers. I will stop sharing so I can see also the.
That's good. Thank you all. And maybe I should go into the, there are some other slides that I will share afterwards with some links and acknowledgement and pointers. But let me quickly share my screen and go to the Etherpad. So it seems that we have 2-3 questions. So I thought is it worth to stay in Graphland when dealing with subslam? Perhaps we use RDBMS when we have needs for subsetting. Anyone to dive in?
I can dive in. It may be true. Especially, for example, I was surprised that KGTK, surprised not, but KGTK uses SQLite, and the performance of KGTK is much better than the performance that I obtained using Spark Graph. So I think, so I agree partially that maybe using relational databases is a good approach, but I also wanted to say that I also wanted to experiment with in the Graphland. So, and in the Graphland, especially when I was using this scalable algorithm, the Pregel algorithm, so I was happy that it could work, but I didn't do any kind of optimization. But I partially agree with that. Yeah.
Yeah, the problem with Pregel, if you look at the actual architecture, right? It's great at processing nodes. In order to process nodes, with Pregel, you need quite a bit of memory,
Yes.
per node. So that is a problem, but it's not a problem for Google, who has a lot
Yes.
of capacity. So that is always the challenge
Yes.
when you're talking with indexes and supporting and moving data around. When you want to move it fast, just like with a highway, right? You're going to have to make that highway wide, and for us, in IT land, that means more memory,
Yeah.
more bandwidth. So there's a give and take there. But yeah, go ahead. My other questions.
No,
Well,
but,
to add to that, but maybe I need some pushback there. So my ultimate goal is to get the subsets, and I'm very bold in the statements in stating that a Wikidata statement without a reference is useless, and that is where I suspect. So currently we are working with very simple subsets, as in only genes, human genes. So basically one arc graphs. But the more sensible pathways, I suspect, need the graph things. And I'm really talking about being able to write a subset stating object X. I'm interested in a subset if X leads to Y leads to Z lead to A. So I want to be able to dictate that more than 2-3 subsets. And
sure, you want to query the relationships. Yeah, we know.
Yeah.
And we know you can do that with RDBMS, right? It's just a matter of partitioning the data, and you can do joins and unions and all that. Yeah.
Okay, then let's add it. Join us in the next hackathon, I would say.
I'm not going to solve all your data problems. I did enough of that for Ericsson, and they've got petabytes. So,
what I wanted to say is that I agree that probably that there is this approach using SQLite. In fact, my short-term plan was to compare the different approaches. So, but that's more from an algorithm perspective. So yes, I agree with that. And if you are expert on that, I would be very happy to have you on board. Yes.
Yeah, I could probably help with. These are just some of my ideas. I've done big data. I'm familiar with most of the technologies. I've got like 25 years in it. But anyway, these are just some things that I've always often thought of when I myself had processed Wikidata. It's good to sometimes just flip things on its head, so to speak, and kind of, in this case, I think getting out of the graph land just so you can quickly create a subset might be the quickest, fastest approach. And then you can, of course, flip it back over and go, make it a graph again. Yeah.
Yeah, on the other hand, yes, but on the other hand, something which is nice and fits very well with this idea of subset is that the input language for us is very natural to express the subset using shape expressions. And in a shape expression, you are really focusing on a vertex and the neighborhood of a vertex. So, and that's for me, it was very natural when I saw in Pregel that they use this lemma of think like a vertex, right? So, so that's why for me it was very natural. In fact, what I did was to implement the validation algorithm using Pregel, and it works. It works, but as you say, it requires a lot of memory. So I mean, it's very natural, but also I maybe. So I agree with that, but I still think that using the graph, thinking like a vertex is a nice metaphor. So, but I agree with you.
And there might be some usefulness there. So
yes,
still certainly to explore.
Let's continue. Postgres has a support for JSON for a while, and it's known that relational databases have strong indexing support and partitioning via file layers to allow lower memory usage. Has anyone done any evaluation of solving subsetting performance with Postgres SQL? I don't know.
Yeah, I guess this was probably back to Jose. if he had looked at any of the JSON processing support, and even SQLite has some, or if he knows of anyone who did.
No, I didn't.
No,
I didn't
okay.
know.
The other idea I had to was that from Presto, particularly ARIA and the link, which allows push-down support now with org files. Has Presto been looked up at as a filter mechanism, perhaps against Progress SQL?
It's the same. I mean, I didn't.
Yeah. Okay. Anyway, that last one though is probably more for you, Jose, to look at into maybe and do some research. A bit closer to Pregel in a sense.
Yes.
In the way it would handle the filtering. So that's definitely something you may want to look at a little bit if you're not familiar with it. Yeah.
No, I know that, and I will look at it. Thank you for the pointers.
Yes.
Yeah,
no problem.
So actually, maybe I kind of said it semi-jokingly, semi-seriously that you should join us. But maybe to emphasize, this is why I also called it a Biohackathon, is that we did this work. I mean, Dan Brickley started it at the Biohackathon in 2019. And what typically happens is that we do a lot so Biohackathon or SWOT for us is an event that takes 3 days. So in those 3 days, we do a lot. And then with a lot of excitement and to-dos, we leave, but then reality hits us. So basically, this work happens in the Biohackathon sphere. And
those 3 days.
Yes, and then we are now documenting. We're presenting this, and we're all pretty close to where we are. But reality is back biting us. But having said that, the deadline for the next project proposals is I think April 4th or 1st. So we might want to take this offline and discuss whether we want to have a next edition of book, and then work on this. But let's move. So, but we can take that offline. Just to emphasize that this is really done in Biohackathon spheres, which really helps.
Right.
The next question is, what is being done to assist the community in exploring subsetting? For instance, dumps has been relatively straightforward to use by general Wikidata user, but it has not been producing the dumps for weeks. Other tools require deep technology insight and/or infrastructure use, with many Wikidata contributors do not have. So I think I can answer it. I think the short answer is currently not, because we are evaluating the mechanism. But the ultimate goal is, so I'm particularly diving into a mechanism called WD sub, for which I use a Docker image, and the ultimate goal is to run those Docker containers, creating the subsets, which will then be either published on some Wikibase cloud or on some other platform. So that's the ultimate goal, to create, like what I said with the Gene Wiki, create some pipelines that can be ticked on and then create a subset. But unfortunately, we are not there yet.
And I would like to add to that my dream would be that you could create from entity schemas, and you could have a button that says, okay, now that I have this entity schema that defines some kind of domain, I want to create a subset from that entity schema. That's my dream, but it is not there. But that's something that could be very nice to have.
And the gossip has been that once we are able to create a great subsets or a series of subsets on a daily basis, there are hosting opportunities which would allow, hosting those subsets there. But we are not there yet.
Jose, do you mean with the schemas, basically I describe the kind of entities that I want using entity schemas, and then I say, click a button and say, give me all those entities that match my schema. That's what you mean, right?
Yes,
in simple
exactly.
terms. Oh, okay. Yeah.
Yes, exactly. For example, I mean, previously in the previous session, Andra saw the entity schema of the Gene Wiki. So it's E37, and in the Gene Wiki, the entity schema is a type expression that is a reflection of it reflects like a UML diagram of the. I mean, you have diseases which are linked to genes and chromosomes and so on. So with that entity schema, my dream is that you could click there and obtain all the genes, the diseases, and so on that conform or that match with those expressions.
Right.
That's my dream. That's what I'd like to have.
I think that you and about 1,000 other people. Yeah.
I'm pretty close there, but it's running on the Sparkle endpoint of Wikidata. And I recently ran it on the DOM hosted by Virtuoso, and I was able to increase the size of the subsetting. So yeah, I think you should get out of your dream and enjoy the reality.
Yes.
Next question. Is there a Wikibase page to discuss about ways how to create subsets? It is something where I'm interested in. And someone already mentions the subsetting, and yeah, I can make a promissory note that we are working on making this into a paper, and then once that is in the case, I'm happy to share that on that wiki project as well. And then final, anyone wants to add to that? If not, the next question is, have you identified Weaviate vector search technology as a valid alternative to your subselect project?
In my case, I didn't.
No.
I will look for that. I will check.